This is question number 2 of my year 10 examination questions. And it says the angle of elevation of the top of a tower from point A on the ground is 60 degrees. Find from a point B 2 units of distance further away from the foot of the tower. The angle of elevation of the top of the tower is 45 degrees. Find the distance of A from the foot of the tower. Before we can solve this question, let's draw it, prepare it in a diagram rather, so that it can be easy for us to solve. So for this question, if this is the ground floor and probably this is the tower, we are told that the angle of elevation from point A, this is point A, let's call this the foot of the tower, right? We are told that the angle of elevation from this point is 60 degrees. Now from this same question, we are told that from a point B, 2 units of distance further away from the foot of the tower. This is the foot of the tower, further away from the foot of the tower. That means you go further from here to point B. Yes, 2 units. And we are told that the angle of elevation is what? 45 degrees. Find the distance of A from the foot of the tower. This is the distance AF that we are looking for. But before we can solve this, you should know that the tower is perpendicular to the horizontal ground, right? So there's a 90 degrees here, and there's also a 90 degrees here, right? So with this is a right angle triangle, and this is a right angle triangle. So I can get the height of the tower from this first triangle, right? Let me call the height of the tower X. Okay, so if I call the height of the tower S, if I take this triangle, this right angle triangle, for example, I'm having the opposite and the adjacent, right? So in trigonometric ratios, what relates opposite and adjacent? That's tangent, right? So that means for this particular right angle triangle, tan 45 degrees will be the opposite divided by the adjacent. So I will have that tan 45 degrees will be equals to the opposite, which is the height of the tower, is X, divided by the adjacent, which is 2 units, right? So from here I can get the value of X. This is the same thing as divided by 1, right? Cross and multiply, I'll have that X is equals to 2 tan 45 degrees, right? And we know that tan 45 degrees is 1 special angles, right? So this will give me 2 times 1, which is equals to 2 units. So therefore the height of the tower is 2 units, okay? So we can now get the distance from A to the foot of the tower, since we've gotten the distance. So let me call this is AF. Let's call this distance AF, since it's from A to the foot of the tower. Now we can also relate this other right angle triangle, opposite over adjacent, right? So since it's opposite over adjacent, we are also using tan theta, right? So I'll have that tan 60 degrees will be equals to, my opposite is X, and my adjacent is what we are looking for, AF. So let me call it line AF. So making line AF the subject of the formula, I'm having that AF will be equals to, if I cross and multiply and make AF subject of the formula, I have X over tan 60 degrees. What's the value of X we got initially? 2 units. So I'll replace that. So I have that AF is equals to 2 divided by tan 60 degrees is equals to √3 special angles. But we can't leave our answer like this because the denominator is in a solid form. So I'll multiply both the numerator and the denominator by the value of the denominator, which is √3. So AF will give me 2 over √3 multiplied by √3 over √3. 2 times √3 will give me 2 √3. √3 times √3 will give me what? 3. So the value of my AF will be equals to 2 √3 over 3 units. That's the answer. Let's go over to question number 3.